right, here we go with our last video notes of the year. This is going to be over section 9.82, and it's going to be based on those formulas that we talked about yesterday. Those formulas we did yesterday were on this orange sheet. We did the sum and the difference, and we're going to be applying those formulas for different types of problems today. So in these exercises, it says to find the exact value of the expression given that the sine of A is negative 4/5 with pi is less than A is less than 3 pi over 2, and cosine of B equals 5 over 13 with zeros less than B less than pi over 2. All right, so what this is really asking us to do is to find the difference in those angle measures and then find the cosine of that. Now, that would be a very difficult thing to do, to actually find the angles, find their measures, and then subtract those two and then do the cosine. That would take a lot of time. But we can use our formula for cosine of A minus B more quickly than we can do all of that. Plus, using this formula is a better way to find this exact value. See, if we used our calculator to actually compute what the angles are, subtract them, and then do the cosine, it's going to be an estimate. So we're going to make sure it's exact. All right. So we are not actually going to figure out what angle A is, but we're going to figure out triangle A. So if angle A is in between pi and 3 pi over 2, which quadrant would it lie in? All right, so angle A has to be in quadrant 3. I don't know exactly where. I'm just kind of drawing a picture here. Angle A somewhere here in quadrant 3. We're told that the sine of A is negative 4/5. So what is that telling me then? Opposite over hypotenuse. So what is the opposite? Negative 4. And what's the hypotenuse? And how did you know that it wasn't the hypotenuse that was negative? Can never be negative. It's defined as the distance. All right, so do we know what this missing value is right here? Is it just 3? Negative 3. So x and y have to tell us direction. So x is actually going to be negative 3. Now we're going to look at the other angle they give us. They give us information about angle B's cosine. So I'm going to draw a picture. Which quadrant based on this information here? First quadrant. So I'm going to put angle B in the first quadrant. It's right there, angle B. And they tell us that the cosine of B is 5 over 13. So what is 5 going to represent? The what? The x, or the adjacent. And the 13 is going to be the r value, or the hypotenuse. All right. Now, I could figure out what this angle is by using trig. And I could figure out what this angle is by using trig. And then I could subtract the angles, take the cosine. But like I said, that's the harder way to do the problem. What is this missing side here? All right, so now I'm going to write down my formula for cosine of A minus B. How does this start? Coco. It goes cosine A, cosine B. And then is it minus or plus? Plus, and then it goes sine A, sine B. So I'm going to have to use my angle A, and I'm going to find the cosine of angle A. What is that cosine? Here's angle A, guys. What's the cosine? Negative 3/5, right? What is the cosine of angle B? Come over to this triangle now, because we're using the B triangle. 5 over 13. Plus, we go back to angle A here. Okay, go back to angle A. And what is the sine of angle A? Negative 4/5. And what is the sine using angle B? 12 over 13. All right, so now we're just going to finish this. So when I multiply fractions, I just multiply straight across. These would actually cancel, but I'm not going to cancel them, and you'll see why here in a minute. Negative 15 over 65 plus negative 48 over 65. So why didn't I simplify this one? I need a common denominator, so I'm not going to simplify it. All right, so now we have a common denominator. We're going to combine these. And so negative 15 plus negative 48 is going to be what? Negative 63 over 65. And that's what the cosine would be of the difference of those two angles without even figuring out what those two angles are. All right. Tangent. Tangent's formula is a little bit more complicated. I want to go ahead and do tangent. I think you guys get the concept, but tangent is much more difficult to simplify. And so I think it's worthwhile to go through it. So this formula goes like this. It's tan A minus tan B over 1 plus tan A, tan B. All right, so we have to use the appropriate angles. So triangle A and angle A are over here. And so what is the tangent going to be there? So I'm going to have 4/3 minus, what's the tangent of over here for B? 12 over 5, right? And then it's 1 plus tangent of A again was 4/3. And tangent of B was 12/5 again. All right. So checking this out, I'm going to go ahead and combine these two. So I'm going to have 4/3 minus 12/5 over 1 plus 48 over 15. Now, you could get out a calculator and type all of this in, but that is actually more difficult than using a method that I showed you earlier in the course. We have 4 terms here. What is the common denominator if I take into account all 4 of these terms? 15. So I am going to multiply each term by 15. So I'm going to multiply this by 15. Now, I can do 15 times 4 divided by 3, or I can do 15 divided by 3 times 4. Which is better? So what is 15 divided by 3 times 4 is going to be 20, minus what's 15 divided by 5 times 12, 36. We have 15 times 1 is 15, plus, what's this one just going to be? 48. Make sure you get the 15 there. What do you think a lot of people put right there? 1, yep, common mistake, plus 48. So now I'm going to get negative 16 over, what's that, 63 again? And we can't do any simplifying, can we? That's 9 times 7, 3, nope, no common factors. So there we go. All right, not too bad, right? All right, let's come over here. We'll just do one of these two. I don't think we need to do both. We're supposed to simplify the expression. When they ask us to simplify the expression, that means we want to get it down to a single angle, okay? Right now, we actually have 2 angles that are getting added. So we want to try to make this simpler. What do you think we're going to use? Our formula, right? Yeah. So our formula goes like this. It goes the sine of x times the cosine of what? Here's A, guys, and here's B. Pi over 2. And then is it plus or minus? Plus. And now it would go the cosine of x and the sine of what? Pi over 2. All right. So now we should be able to evaluate anything that has a pi in it. If it has an x, we cannot evaluate it. But if it has a pi, we can. What is the cosine of pi over 2? Thinking of this unit circle, right here's pi over 2. That point is 0, 1. What is the cosine right there at pi over 2? So what's going to happen to this term? It's going to just be 0. It's gone. And now we have the sine of pi over 2. What's that going to be? Times cosine x, and this is just cosine x. Does this answer make sense? Can somebody explain? I'll answer that question myself, yes. Can somebody explain why it makes sense, Drew?
I was just going to say for one of or properties of sine pi over 2 minus whatever the other angle is equals cos of that angle. So
right. So talking about this property we have, where is it? This is close, right? This one right here, this co-function identity. It's not exactly the same though. But guys, think about this for a minute. If I'm graphing the sine of x plus pi over 2, what is that type of shift going to be? A shift to the what? To the left pi over 2. So I would do my key points, 0, 1, 0, -1, 0, 1, etc. What is this new graph without a shift of 1, 0, -1, 0, 1? What's that? Cosine. See how it's really the same thing. Okay, that's what we're doing. All right. Should we do this one or not? You think you can do it? Okay, let's not. All right, let's go down here. Do you want to do the easier problem or the harder problem?
harder.
Okay, harder. Let's do that. Okay, number 10. Number 10, guys. This is going to be pretty challenging because we have two not double angles, two differences in here that we're going to have to simplify. All right, so watch. On this one, this is going to turn into sine x cosine pi over 2. Is it going to be minus or plus? Minus, and then it's going to go cosine x sine pi over 2 plus, how's this one go when it's cosine? Goes cosine x cosine pi over 2, and then is it minus or plus? Plus. Isn't it great when you memorize a formula that you don't even really have to memorize, but you guys got it. There we go, equals 0. All right, now anything with a pi in it. Remember, guys, these are terms. I have 1, 2, 3, 4 terms, okay? Any of these terms that has a pi in it, I'm going to evaluate. Cosine of pi over 2, what is it? Times sine x is just going to be gone. What's the sine of pi over 2? Times cosine x. Negative cosine x, done. Cosine of pi over 2, 0 again. Don't need to write anything. Sine of pi over 2 times sine x is sine x. All right, equals 0. Tough problem here. Normally, when we have a problem like this, we want it set equal to 0. But in this case, it's easier if I take this cosine over to the other side. We get sine x equals cosine x. There is no algebraic way that I can actually solve this. I have to visualize my unit circle, and I have to think, where on the unit circle does the sine of an angle have the same answer as the cosine of that angle? 45, okay. Look at our directions now. Okay, great. Pi over 4, I agree. Is there another place on the unit circle where sine and cosine have the same answer? 3 pi over 4, do you guys agree?
No.
No? Uh-oh.
5 pi over 4.
5 pi over 4. And those would be our two answers. Okay? All right. I want you guys to try this one now. I'm going to be working it up here, but I'm not going to talk you through it. I want you to try it. If you get stuck, you can look up here. I'm going to go through it kind of slow, so I want you guys to try to beat me with it, okay? See if you can get the answer faster than I can. I'm going to have to write really slowly. Raise your hand when you think you know it. couple. Sam, what'd you get?
I got
Pi. Anybody get something different? Anybody get pi? Good job. You all are correct. The answer is pi. There's the way it's done. It's not too bad. All right, guys, that is it.
Bye.
Bye.